Um, hey, so can you give a brief, like, 1-minute intro about yourself? How much leetcode have you done? What you're applying to? Maybe like what college you go to make it more unique since you're anonymous anyway. Things like that.
Yeah, so I'm a sophomore at the University of Michigan, and I was applying to interviews and just wanted to get some practice here, and that'll be a good practice. So
Okay, cool. Have I done a mock with one of your friends, by the way? Because I think I
yeah,
interviewed like 2 or 3 people from there already.
yeah.
Okay, makes sense. Okay, cool. Okay, so the first problem I'm going to give you is, oh yeah, let me reset this thing. Is okay, great. So you have a integer array nums, and it's made up of a bunch of numbers. So let's say it's like 311, and you can do one operation over and over and over until you can't do it anymore. So you take two adjacent elements, and if they are the same, then you combine them. So for example, this 311 would just turn into 32. And basically return the array after I can't do any more of these combines. So return array after I can't do any more combines. Okay.
Okay, okay. So just to think about like edge cases, is would there be like should my code account for like empty arrays and stuff?
Yeah, so what do you think is reasonable for a empty array? What do you think you would want to do?
Probably just return the exact same thing, right?
Yeah, exactly. Yeah.
And yeah, beyond that, I don't think there are many more edge cases. Okay, so take two adjacent elements and they're the same. So what do you mean by combine? Is just like add them together or
Yes, add them together.
and is there like multiple like ways to reach the end or um is
Um,
it is it like deterministic solution or
it is deterministic, yes.
okay if there's something okay so just a few thoughts like generally we want to see uh like like the brute force approach of like updating it each time seems too slow because I mean there could be like many combinations and I
Mhm.
think that would be like they'll probably be like n is it exponential or maybe just n squared? I'm not entirely sure, but yeah, I think the brute force is like n squared because um you have to each time you update it, you still have like a n minus one, and then it would be like yeah, like it'll go all the way down to one,
Mhm.
or like what the minimum is, so it's like n squared. But I'm trying to think of like a more efficient solution, perhaps. Since like you sort of get the hint that it's like a deterministic solution, I was thinking that like um you could probably like greedily combine it, but it is true that like there's like certain dependencies that maybe you need to combine stuff later on in order to get like a combination at this point. So like for instance, if I had like one and then like but like probably like four, then like two, comma two. You can't just do like a single pass through. You would have to um so and I think like the position doesn't really matter. I was thinking maybe we can have like two pointers starting at the end and the beginning and like close them in, but I'm not sure if that would work because we don't know where the like dependencies are. So uh
Mhm.
um I think I'm gonna try to like work through some examples to maybe get like a better grasp of like the various edge cases and stuff.
Sure.
Maybe to get better idea. Um, okay. Oh yeah, I think okay. Like in this example, there are just like numbers are like separated. Like you can sort of like partition it off. Like, oh, we'll never reach the sevens will never touch. And so like how do we what is like a good way of storing it? How do we know this? Like
Mm-hmm.
perhaps we should like no, we cannot sort that because the actual order of the elements does matter. Um is there like some sort of a greedy approach that I think like might work here? Because if we want like an O of n solution, uh um
Well, ideally, we just want the best approach we can get. So if we can
right.
get an n, we can get an n.
Okay, I think yeah, I think a key here is that like evens and odds or no. Okay, so combine them with a duplicate. So it's like you're always gonna multiply it by two. Um Um, maybe okay, okay. How can we improve like the brute force operation of just going through and checking out duplicates?
Mm-hmm.
Um, how can we improve that? Then I think like there's like I this might sound weird, but there might be like because when we combine it, it's just like adding them together, right?
Mm-hmm.
So are there like negative elements or
Does it matter?
no? Okay, yeah. Okay. I was thinking like, oh, if there's negative elements, we might have to like change the approach. Maybe you sort of see you go on one number and then you see if the next number is like larger than that, and like the idea is that if it's larger, it will that number will never if you keep on going that direction, that number will never combine to like touch you. Um, Same thing on like on both sides, but if it's like negative, you should check like if if you have like -3, like 3 combined with other positives will never
So you would never combine them unless they're the same.
right. So the idea is that when you combine elements, they will always like they will always grow. So if we have like a sort of like valleys, I think you just never be able to combine it. Like if you have like 4, 2, 4, 4, we'll never be able to combine any of the valleys. Um, that's just like one
Okay.
heuristic. But then how can we apply this like to like other stuff? So this is can be used to detect like oh the ones that won't get any combinations. Um, but just because it's not valid doesn't mean that you can like combine it. Like okay. Like, I think maybe we should have a one pointer on the current element we're on, and then while we see smaller elements, we should like do the rest of the work there. Like if we see larger elements, that element is done for. Like we can no longer do anything about it. So if we see like a 5, we definitely can't combine 4. You know what I mean? And so 4 definitely has to go. And then if we see like a smaller element, we should iterate. We should yeah. So if we see a smaller element, there still is hope. But generally, so it's probably like some sort of sliding window approach where if you see larger elements, definitely, yeah, some sort of sliding window approach where as you encounter smaller elements, that's good. But if you encounter larger elements, you just increment left. Like if I left on 4, and then my right starts on 4 as well. We increment right until we continue to increment right until we encounter an element that is larger than our left. Because then once we get and then we do like combinations along the way.
Okay.
But it is like true. Like, what if we have like, I think we can maybe keep track of like the sum of the elements to the right of our, like if our left is on 4, we should keep track of the sum. And once the sum is greater, then we can't do anything about it.
So okay, so once the sum is greater, you can't do anything. Oh, because if you combine stuff, yeah, I don't know if that's necessarily true.
Uh,
Like if you have some big element here
mhm.
and you have some like small elements and the sum is greater, but maybe down the road you'll be combining stuff. No, I guess that might be true. I think you're right. I think it is true.
But I guess it is difficult to say like how can you guarantee just because it's smaller doesn't like
Because
okay, so
in order to if the sum is bigger, in order to combine with the 4, you'd have to have combined everything past the 4 as well. So then when you combine all that, that will be bigger than 4, right? Like if you know the sum is bigger and you can't combine anything in there, then it's guaranteed.
yeah, I think we keep one at the element we're on and then keep on going right and then doing the operations while also keeping track of the sum. And once the sum is greater, we'll increment, like we'll change left. So we have one left to where we are, and then we'll increment right. And then if the sum is greater, we will make left equal to right, I think. And then along the way in the middle, I think it's okay to do operations. Like I would just like, so if just like for this problem statement, would I like be returning another vector, like another array of nums?
So you'd return nums after all the combinations are done. So you would just return like this in this case.
Right. So like I can create like a new vector, right?
Yeah, that's fine.
Yeah. So and that's just like O of n. So I think I'll just increment right and do operations as I can, I guess. The issue is how to keep track of like multiple nested operations. Like so if I have 4, then I have 2, keep on incrementing. Like I think this greedy approach will like you lose track of stuff in the middle, which is get bad. Is this on the right track in sort of like sliding window, or?
So I think you are okay. It's like okay. I think you can do it this way, but I think you are overcomplicating the solution. I'll just say that.
Are you suggesting that the n squared solution is best?
No, I'm saying your solution tracks a lot of things that aren't necessary.
Mm-hmm.
So there is an order n, which is what we are looking for. I think
Right.
n squared would be pretty simple. Like you just keep going through arrays and you keep like matching elements and you combine them until there's nothing left. But there is an order n. What you're doing is overcomplicating the
Yeah,
solution.
yeah, I think you just like maintain a stack and then just if you maintain a stack of elements and then we combine it, and then if you're able to do at the top. But if you do like combinations and it's greater than the top of the stack, oh, so it's like a decreasing stack. Like if you have a increasing stack, it definitely adds like the same reason that we applied here. So I add these elements to my stack, and if it's increasing, then if we see a number that's increasing, then we should like clear the stack. Well, like
I see. So you have a stack of elements, and if you see a number that's increasing, you clear the stack because you can't combine.
uh yeah,
Like if you have like 4 and then 5 or something.
yeah.
Okay, but then how do you deal with this case where it's like 4 and a bunch of numbers? Like, would you keep it all?
Shit. Like, I think the idea is if we were able to combine it, it will like clean up the stack. So I guess that's like useful. Um,
Okay.
um,
Okay, so why don't you, maybe this will help you out. Go through this example and think about what operations happen and then what's the end result. Maybe that'll give you a better idea of what you need to do.
yeah, so I'll push 8 to the stack. I'll push 2 to the stack is decreasing. It's fine. I'll also push 2. But each time before I push it, I'll like compare it to the top. And if it's equal, I'll like combine it. So then I'll combine it, and then I'll combine it, and then I'll keep that on the stack as well. And then I'll go to the next number. If it's equal to the top, I'll push that to the stack as well. And then
Yeah, so can you actually write out what the array looks like after every step? I think that'll help you out.
yeah.
Okay.
16. And then like 16 could still combine with the other stuff, and then I'll add 1, and then I go to the next one and I see that I'm able to do it. I'll add 2, and then I'll check 4 and I see that, okay, 4 is increasing. So I'll clear my stack and push these all to my answer. And then I'll just restart my stack with 4 like this, I guess. I'm trying to think of like any edge cases that this doesn't account for. I said if it's greater than the top of the stack, I should always clear. I don't know if that's true. Yeah, it is true, because if it's greater than, notably, the stuff that's at the top of the stack is also like the stuff that you need. It's like a barricade. Like if I push 1 and then I see a 4, no matter since 4 is greater, it will never combine with 1, and so it's too late. Like you can't do anything about it. So you can just clear the stack. So I think, yeah, generally you can clear the stack if you encounter a number greater, because it'll never combine with the number at the top, and etc.
Okay. Yeah, I mean that makes sense to me.
Yeah. Okay. Yeah, I'll start coding.
Sure.
So I'm gonna create an answer that I'm gonna like copy in at the end, because we want. Then I'll have stat. This will be a. What are you saying? And then for mm, I'm thinking if like the indices actually matter. So we need to check the current num. Um, so should we push the original first one to the stack? I think we can just handle it generally, like uh if stack is empty, we always push maybe because we're clearing. Um,
Sure.
because we're gonna access stack at the top, so we don't want like six. There might be a more general way of handling this. Like I'll modify it if that is the case. Push. So if it's not empty, we should do some things. We should do and try to do an operation. So we should see. So if it's not empty, we can access the top,
Okay.
and then we'll try to do a few operations. If equal to top, if it's equal to top, that means that an operation can be done. And then we'll just do if it's equal to the top, we should. Okay, if it's equal to the top, we should pop it, and then we get. It's like the idea that we should also clear the stack. If we should clear the stack if the new number that we created is greater than because we're gonna create a new number, and if it's greater than the current top, then we should just it's the same thing. It's the same idea where we clear. I'm gonna create like a helper function just to
Okay, sure.
clear. So the same vector. And the goal is to clear it. So anyway, so we're going to do the operation, which is just like if the integers are too large, we might need like a different value or something, but that's okay.
Oh, we can say it fits in an int. We can say no matter what you do, it always fits in an int. That's fine.
Cool. So here, I think we need to do like a while loop, I guess, to sort of see how many operations we can do. So if num, so while num is top, while num is equal to the top, we should do some things. Okay, there's like an order of operations that needs to be done here. Like we should push back the stuff in currently in the stack and then push back our thing. So I think like we're gonna we can handle that with this. Only if we clear it though, so we shouldn't. Maybe we can pass it in right here. Okay, I'll just think about that later. But if the new num is greater than this should be separate logic. So while it's equal to the top, we should when adding is it insert push new num. Oh wait, while it's good, we should oh god. Oh, this is bad.
Yeah, so we're at about like 25 minutes left. So you can continue this, or we can just move on to the second question. You can come back if you want to. What do you want
Okay,
to
yeah,
do
let's
that?
move on. definition.
Okay.
Yeah, the general.
Yeah, because I think you're kind of going down like a weird rabbit hole that's kind of confusing. Okay, so for the second question, you're going to make a ride sharing system class.
Okay.
And so it's going to have a bunch of things. So there's going to be a class called add rider. It'll be void, and it'll take and it'll take a rider ID, and this basically adds a rider to the queue. So it's like a FIFO queue. Then we're going to have void add driver ID. This will add the driver to the queue. And so these are, you could think about separate, like two separate FIFO queues, where if I add a rider, I have a rider. If I add a driver, I have a driver, and they're separate. Then you have another thing that you have an int array or pair, whatever you want. That's match driver with rider. So basically what this does is it returns int array or pair, whatever you want, of the matching pair. So because I have two FIFO queues, the basic logic is like I just take the first available rider and the first available driver, and that's what I want. Now there's one more thing, because with just these, this would be pretty simple. There is a cancel rider. And this means if my rider is in my queue, get rid of it. Get rid of the rider. So, if I put in a rider with like ID 1 and then I cancel, that rider needs to get removed. Now, if they are not, then do nothing. Okay?
Okay.
And there's one more criteria that's going to be important for this problem. And that is IDs are, well, not necessarily, but make it a little bit easier for you. So strictly increasing for riders and drivers and all unique. So I guess, so you could think of maybe not all unique, but like unique for each. So basically like rider IDs are strictly increasing, driver IDs are strictly increasing that are passed into these add rider and add driver. You will never like have the same rider come back, never have the same driver come back. Feel free to ask anything you want to.
You mean like match rider with driver with rider, right?
Yes, sorry, yes.
So this will just do at the front of both queues. We just add those two together.
Yes. So match driver with rider. Yes. So I'll give you an example. So let's say we add, we add rider with an ID 3. We add driver with an ID 2. Actually, sorry. So IDs are not strictly increasing, but they are unique. So rider IDs you'll never get the same one twice, but they can be all over the place. And also if I like add and remove a person, I will never like add them in later, right? So anytime I call add rider, you're guaranteed this is a unique number, and add driver is also a unique number every time. Okay, so let's say I do this, and then I add rider 1, and then I call match. So I call match. So this will basically return to me driver 2 and rider 3, right? Because they're like at the front of the queue. And now the only person I have left is 1. And then I add driver 5. Let's say, so now I have a driver 5 and a rider 1. And then I cancel rider 3. So because the rider 3 has already been like matched and they're already out of the queue, this does nothing. So this is nothing. And then if I do another match, then I would return whoever's left. So it would be what, depending on which way you return, either the driver or the rider, but basically the only person I have is the 1 and the 5. So I guess it would be like this way. And then one other criteria is if I call match and I don't have a match, you can just return like -1, -1. So I'll add that as well. So if no one in queue for either rider or driver, return -1, -1. Okay, is that pretty clear?
Yeah.
Okay, great.
So general idea is that the cancel writer is like everything else seems fairly straightforward, but the cancel writer, um, we want that to be like an O of one time, ideally, right?
Yeah, so ideally we can't just go through the writer queue and pull them out. Otherwise, this
Mm,
would be a very easy problem. Yes.
right. So, um, I was thinking just having like a linked list as like the queues would be a adequate solution. Oh wait, no, then you still have to iterate. Maybe like I'm thinking like a map of the IDs to their position in the linked list, then something like that. But um,
Okay, so you're saying you'll have like a linked list for each, and then you'll have a map for
mhm,
like the person and their position?
yes, position in the linked list.
Okay, but what about, so these queues move, right?
Right.
So if I pop the first guy, then everything moves. So how would I like what do you mean by position exactly? Like
Because the queue is like first in, first out, right?
yes.
So we can like if we model that with like the linked list, it creates that order, and then when we pop like if we pop the head or the front of the queue, we just have like the logic to handle that, right?
Yeah, so if you pop, so let's say for example you have writer like 1,
Mhm.
then you have like 3, 2. Like can you show me how you would store this? So this is, let's say this is your linked list of writers. How would you store
Yeah.
this?
So one, since it's unique, would point to this like linked list node. Three would point to this. Two would point to this. And
Okay.
so if I pop one, then I should definitely remove that from the map.
Okay.
And then because maybe it might be like you might reuse it, but then and then I'll just handle like the linked list logic of okay, if it was head, we like remove it and do like the previous and next.
I see. Okay, so basically you like store exactly where it is in the list. Okay. And then
Yeah.
how would your driver look like? Would that be a linked list as well?
I think the driver can just be the same thing. Oh wait, you're not canceling writers actually. Oh yeah, you're not canceling drivers. I mean, so yeah, no, you could just store that as like a normal queue for the writer driver.
Okay. Yeah, I think that makes sense. And then what's going to be the big O of all of these functions?
Well, if we're having I think it's just all of one.
Okay.
Yeah.
I think makes sense because yeah, with a linked list and a map, you can have O of one. Okay, so basically cancel, you would just pop it from the thing and update the pointers.
Yeah.
Add would add it and you add it to the map. Match would remove stuff appropriately.
Mhm.
Yeah, I think that makes perfect sense to me. Okay, so basically gonna have a linked list and a map here, and O of one for each of these. Okay, yeah, sounds good. Feel free to code it.
Yeah, I was gonna use like the STD list. Does that seem fine? Or
How
should I
does
like
that work?
it's just like it's in the STD where it gives you like the functions that you need, like pushback and stuff.
Does it give you it's like a linked list that's like made for you or what?
Yeah, it gives you like push back and push forward.
Okay. Do you still have to update pointers?
Um,
Like how does that work if you push from the middle?
I think you just yeah, you have to set the pointers yourself because we have like pointers to the nodes in the linked list, right? So
Hmm.
if we like because that's like sort of separate, so we would still need to update that ourselves.
Okay. Yeah, as long as it just gives you like list nodes, that's fine. As long, yeah, if it doesn't do like 50 things for you, that seems pretty reasonable.
So uh, so I'm going to store a queue of X for the store queue of N's for the drivers. Uh, then we have a we map the rider ID to I wonder what's this. Okay. Um, list of we store it as pointers. Um, okay. We'll probably need like dynamic memory allocation as well. That's okay. Map with their writers to their position in the linked list. Okay. I'm getting color. Wait, expected parentheses or oh yeah, because it's a classic image. Like that. Oh, I didn't click that. Oh shoot. Oh, what's that? What I guess? Template parameter. Wait. This. Okay. I might have to like look up the exact syntax later.
I'd look up. Just look up this, and I'll. You can look it up right now. It's fine. So
Oh,
just
okay.
look up list syntax. Yeah. Because you have to run your code. So.
Yeah. Oh. It should just be this. Wait, I don't know why.
What's the error it's giving you? You need like.
Can't do pointers? Oh, sure. Wait. Is it int, which maps to a linked list? And then okay, I think okay, I'll try with this, but I think it won't work. It won't actually work.
Okay. We'll pretend it does, and then we can debug after. So basically, this is a list node, right? Or that's what you want it to be?
Well, yeah, it'll
Or
be
like a pointer to a list node or something.
well, it creates a list itself, right? And then you get like oh, you're right. List node. That is yeah, I'm looking at it right now. It's actually pretty bad. It's just like a deck, honestly. Oh shoot, I thought it was like a actual like linked list node. Oh,
I would just probably save time and make a linked list node because it takes like 2 seconds. Because I don't think a deck works.
list node. So we just have. Oh, but I guess I'm just doing it myself. Oh, maybe. Oh God. Not sure why it's giving an error.
I don't know. Well, you do also have like stuff on the top you might need to comment out. Like you have this code that's buggy as well, so maybe comment it out or something. But incomplete. List node is incomplete until the closing thing. Interesting. Yeah, I don't know.
Finish this. This.
But we can just write everything else and then like go back and fix it later.
I think so if one is empty, we should just return -1.
Mm-hmm.
Cancel right. So I think just we should probably writers, but then we actually have like a list of nodes.
If you have a deck of list nodes, does that even
Yeah,
work?
I think it's because you would have to create like something else to store like the actual.
Yeah, so you need a list node and then you need a linked list class, which is just like another 3
Yeah.
lines of code. So maybe you can do that. Yeah, I guess it's a problem. So like think about what you'd need here. Because I don't think a deck of list node works.
Um, I'll finish that if writer's left front.
Okay.
Okay, I think like typically the typical convention is have like some sort of like have some sort of like dummy pointers, but
Yeah, I mean, there's a bunch of ways you can do it. Whatever makes sense to you, it's fine.
let's not that. But it's not like null pointer. Okay. It would just be like 0 or something. Return drivers up front. Cancel writer. So this idea is that you want like the specific list node. Okay, like so we want a pointer to a list node. So
Yes. You want a
this-
pointer to a list node, and then, like you said, you need to move around the pointers around it to get rid of it, right?
So the general idea would be, without thinking about like the edge cases and whatnot,
Mm-hmm.
we should check if it's the head, and then we should also check if it's the tail. Sort of things.
So if you are familiar with like the dummy nodes, it makes this stuff a lot easier because then you don't have to check for anything.
Yeah. I sort of forgot. Let me think. This node head.
Like you can basically have a head and a tail point to each other, and you always just insert the tail and you pop from the head. Like insert before the tail and then pop right after the head, if that makes
Yeah.
sense.
Okay. So like these are like dummies, I guess.
Yeah. You just have to have them actually like point to each other in the beginning.
Mm-hmm. Point to each other. So you mean like if we're
like tail net or head next has to be tail, and then tail previous has to be head. Yeah.
and then
Yeah.
and then should we have like I was thinking like, oh, maybe we should set like the ID to be something. Since there's no like -1, right?
Yeah, you can just say -1. That's fine. Makes sense.
Okay, so right, so when it's an insertion logic that we actually like remove it. Anyway, so we do writer. I think we have to care about like this. So we're removing writer. So the guy before writer will be pointing to something bad. So we should do like this. So the guy before writer should point to like something good, something valid. But similarly, the guy in front of me should be pointing to something good. So it's like this. I think.
So this is not quite right. It's pretty close. So think about like maybe draw it out or something, but you don't have it quite correct.
So the pointer to a writer, and then the guy pointing before me will be pointing to like junk when I do it. So, oh shoot, I see.
Yeah.
Yeah, that's it. Okay. And then,
Okay. And then so in here, what happens if this is not in our map?
cancel writer. What does it say? If they're not, then do nothing, right? So I should like handle that. Equals new writer. Yeah. And then we're gonna remove it as well.
Okay.
So
So in C++, do you have to, I guess there is no garbage collection, right? So you have to like manually erase.
yeah, you have to delete.
Okay.
So it's just like this. But for some reason I'm getting an error. Let's see. Pointer to this node. Is that
Yeah, I think you're still getting an error here. And you're getting, yeah.
wait, oh my gosh. Yes. Okay, this should be good now. Okay, now writers is bad. Let's do add writer, so I'm not sure what is there. Oh, I see. Wait, no, you can. It's only for keys that you can't have like list node or something. You can have list node as a value.
Okay, so it looks like you need these to be pointers. So it needs to be list node pointer, pre-even list node pointer next.
Yeah, you can't. Yeah, if you nest it, it's like infinite recursion. Yeah, that's really bad. Okay, so if it's a head, it's a yeah. Oh my gosh. If it's head, we're accidentally the pointer. So we need to. Oh wait, but head next is also list of pointers. It's fine. I'm not exactly sure. Next is part of it. Oh, okay. This. Okay.
And from what I'm reading, it says for the head, like you can't do, or maybe you can, but okay, there we go. Okay.
Yeah. Okay, add a writer. So writers. So when we add the writer, we want to basically create a pointer to the writer. So like this. And then, oh sure. Writer's writer ID equals. So this will return a list node, and then we'll do we append it to the tail. So we do so we should like take the tail right now. So int tail wait. Uh, so we have the tail. Oh, it's tail.
Okay.
So this is a pointer to the tail. So we can just do.
So this needs to be tail, like if you have a dummy node. So basically, I can show you real quick. So your head is here, your tail is here. You're never inserting past the tail. You're always inserting between.
Right. Oh,
So you would insert here.
yeah. We want to maintain the dummy node thing.
Yeah.
So then okay, writer's writer ID. We didn't instantiate that.
So here you're modifying your tail to be that node. It needs to be like the tail and the head never change. You just need to put the node in front of it. So it'd be like tail previous is this guy. And then there used to be a tail previous, so you need to update that correctly as well.
So why can't you just change the tail itself? Or
so if you change the tail itself, then it's not a dummy node. It actually is a real value. And if you remove it, then your tail is gone.
if you change it.
So the idea is you only put nodes in between here, and you
I was
only
thinking
remove
like,
them.
but like after the fact, can we like just set tail to be? Can we just set tail to be no pointer, and then let that be tail? So like, like.
If you do tail previous is this, tail next is null pointer. Well, yeah. So if you do tail previous, you can. Oh, if you set tail to it.
Yeah.
If you set tail to it, then the node is like the tail is gone. Right. Oh, I see. I see. You're basically saying like change the tail to be the new node, and then I mean maybe I don't know if the nodes would work correctly or like the links and stuff.
Logic.
Okay.
Yes.
So tail previous, tail is writer. Okay. Temp next is tail. Tail next is null pointer. Tail. Yeah, I want to say that works. Yeah. Okay.
I didn't create a constructor, so I actually have to like fill it out by hand. New writer. Okay, this is gonna all be no pointers. It's fine, but the ID we fill by hand.
Okay.
Oh, should wait. We're doing. Wait. This, and then we're filling in the pre, and then so we're making this. So tail is a pointer, right? So it should be pointer. Okay, so we're adding something back, so we don't need to modify anything with head or anything. And if we do modify anything with head, that would be like right here, temp would become head. So we're adding node, and then let me just read the thing you wrote in the beginning. Add writer. You just add the driver to the queue.
Yes.
There's just like thinking through any bugs. Like, okay, so if
the writer, there is. Do you see the like the squiggly stuff like on 131? This is like invalid and stuff.
Driver stuff. Okay, yeah, I think it's because you have to do this. Oh, writer queue dot.
So you want. So this is.
Right. Yeah. You just need to dereference that.
Okay.
I think. Oh, sure.
Okay, so let's stop coding, I think, because we're like 5 minutes over. So let me ask you some questions. So what does driver's front do?
Driver's out front returns the front of the queue. And yeah, we do need to pop it. So I forgot to do that.
Yeah. So so you need to pop, and the head is actually, you shouldn't be returning the head, you should be returning head next, because head is a dummy.
Yeah. Yep.
Okay. Okay, so let's just do feedback. Yeah, because we're like 5 minutes over anyway. So
Yeah.
what do you think? What do you think you did well? What do you think you need to improve in?
For the first problem, I definitely like just wasn't thinking like properly. I sort of just like overlooked the fact that a stack would be like really good here.
Mm-hmm.
And then when I was like actually coding it, it wasn't like super general. I was like thinking about like the edge cases, but I should have like made it more general. So that was pretty bad.
Mm-hmm.
Um, for this one, I was like not super comfortable with like the STD list, or I'm not even sure if I know like there's some like linked list implementation in C++, but I
Mm-hmm.
still like forgot it. So I had to just like do it. I should have just like did it from scratch in the first place, I guess.
Mm-hmm.
Um, I guess yeah, I was like not very comfortable with like the dummy stuff, even though it's like very useful. So yeah, I guess
Okay.
I
Yeah.
did
So
I
all
did
right. Go ahead.
yeah, I did like okay with like rearranging the pointers and stuff. But yeah.
Mm-hmm. Yeah. So I think so for this first one, you kind of so you asked about the constraints. So one thing I wrote. So you did restate the problem. I said you didn't ask if there's negatives, and if you don't ask if there's negatives and you know that it doesn't matter, then that's fine. But because you were like, oh, if there's negatives, I can have this like other solution where like negatives and positives will be split and stuff. So
Mm,
if you ask about like constraints, if the thing you didn't ask for matters to you, then you should ask about it. If it doesn't matter, then you shouldn't. And so
yeah.
because you said it matters, now I would like deduct there because like you didn't ask. Does that make sense?
Mhm.
So for what it's worth, it doesn't really matter. And yeah, and then you came up with brute force, and you were like, "Can I get a hint?" And I was so basically, in my opinion, this problem is like I wasn't sure if you were gonna solve it in like 2 minutes or you'd struggle because I never asked it before. It's a
Yeah.
pretty state
Straightforward.
very straightforward, yeah. So all you need is just a stack, and you just keep checking for the last two things. Like all those
Yeah.
other things you did was like, oh, if I do this, I can pop it off. If I do that, I can pop it off. You kind of went into this rabbit hole of like never-ending edge cases. Um, and then you were like, oh my god, I'm so confused. Like I don't even know what I'm writing anymore. So that's why I was like, I feel like it would be a good to it would be a good time to go to the second problem because I feel like you weren't close to the solution. And it was also very hard for me to give you a hint. I can't be like, well, if you just look at the last two numbers, what should you do? You know, like, uh,
Yeah.
so, so this one I think kind of like tests your like just fundamental like problem solving. And this is a pretty rare type of problem. So like, you know, you have to kind of that's why I said like just walk through a couple examples. I think that would have helped you, and you would have realized, oh yeah, if I walk through the examples, basically anytime I have two elements that are the same, I can just like do the combine, and then it always works out that I'm only combining the last two elements of my stack all the time. So that's
Yeah.
literally the solution. It's just like append to the stack, and wherever the last two elements are the same in a loop, just keep combining. Um, so I guess it's good to see that like for an intern level, this isn't like a super easy problem and super obvious. So it's good to calibrate this one. Um, okay,
Yeah.
so yeah, so I think that was the main thing is like you need to yeah basically like slow down, maybe go through some examples if you aren't sure what things are supposed to look like, and that can help you like if you're not seeing a pattern, then write some examples for yourself and then like walk through them really quick and be like, oh yeah, okay, now it's this thing. Because you don't want to make something that's like, oh, here's like the 10 edge cases I have to look for and now I'm going to write the code for this, uh, because it's not very practical. So I'd say that's the first thing is like I think if you like because you struggle in the problem solving, I would say like your problem solving can definitely be improved. And a lot of people either memorize solutions or try to pattern match or whatever. But you should try to like look at every problem as a unique problem and like actually think and not just like what pattern does this match, what pattern does that match. And
Yeah.
I try to do as good job as I can of finding problems that are kind of unique that are very rare so people can't just pattern match and then regurgitate some neat code 150 thing.
Yeah.
Um,
I just like sort of forgot that stack existed. Yeah, that's pretty bad.
yeah, makes sense. Okay, so the second one, you yeah, so you came up with an approach that I like I did this problem once myself, so I didn't know like what are all the approaches. You came up with
Mm,
one that makes sense to me. You're like, okay, a linked list map, I'll know exactly where it is, I'll be able to find exactly where it is, I'll be able to pop it. And I was like, yeah, I think that makes total sense. And I think where you really fell apart is you were like, I'm gonna use this C++ list thing, but you didn't really know how it works.
yeah.
And then when you were writing stuff from scratch, you didn't know how that works very well either. So I think that like if I had to guess, you just do a lot of stuff on LeetCode, and then if you have to write stuff in C++ outside of LeetCode, you're not like the best at it. So if I'm
Uh,
like, go write something outside, like you'd be like, oh, but like, can you give me the function? Can you give me the class? Like, I think you're like, it's okay to have not great language familiarity, but it's like, what if you need to make a linked list or a class or whatever, and if you can't do it in the language that you pick, then that's not good. So you definitely need to get more familiar with like how things work in C++, like the yeah, basically how to write different things. I did start learning Rust, and I know linked lists are like a huge pain in Rust, so it's definitely like a disadvantage. C++, maybe you could argue the same thing. So obviously you can just like pick Python and then it's easier, but if you want to stick with C++, you need to know it well enough to be able to do these things and not like if you have a logic error in a constructor and I have to tell you like, oh hey, this needs to be a pointer, then that's not good. Does that make sense?
mhm.
Okay, so make sure you know all the like common data structures very well in C++. So be able to like make a tree in C++, a linked list in C++, whatever. And I think one way to practice that is you can literally just go like look up the common data structures, which ones are a huge pain in C++. Maybe things with pointers like trees, linked lists, things like that. Make it from scratch and then use it to do some stuff and be like, okay, now I know exactly how it works. Now I know exactly like what I need to do. And
Yep.
yeah, and so there's like two solutions here. You pick the one that's harder to code. So obviously I'm not going to be like, oh yeah, you can do, one or the other. I think big O, they're the same. The solution I actually came up with was because your IDs never like I told you your IDs are always unique. You can just have a map of like what IDs are in the queue, and then whenever you cancel, you just have like a cancel map as well. So like if I have like person 5 in my queue, they'll also be in like a writer map, and then I can just throw them in a cancel map. And then whenever I pop from the writers, I just check, are they in my cancel map? If they're in my cancel map, then I canceled that person. Does that make sense? And then you can just use so it's like two maps and two like decks or something. So that
Uh,
would be a lot easier to code.
so is the map like sorted, or I mean
No, no,
like,
no. So
oh wait, yeah.
so
It's like,
basically, it's just like if so I have a writer map, right, of like every ID that's in my map, every ID that's in my queue. Sorry, right? Does that make sense? So whenever
yeah,
I go to cancel, I just check like if in writer map, add to cancel map as well. And then whenever I uh, do the match, I just check like, are they in my cancel map? Because that means this person was invalidated. If not, then do the match. And
yeah,
if and while the front guy's in the cancel map, just keep popping off until you get a valid person or until you're like out of entries. Um,
yeah. I see. Yeah, that
yeah,
makes sense.
yeah. So, but like this approach, totally fine. Good problem solving. You figured out very quickly. And I think the bigger problem here was just like your language like skills were not good enough. And so you
Mhm.
definitely need to work on that. So I'd say those are like the two things: is like A, work on better fundamental problem solving, and B, be able to code every single data structure in C++. If I ask you to write a class in C++, something with pointers, something whatever, I know it can be like a pain, but you really need to know that stuff if you're going to be picking it. And and let's see if there's anything else in particular. I don't think so. But yeah, like it's a pretty big red flag in my opinion, where it's like you have to make a list node class and you don't know that like, oh, it needs to be a pointer instead of a value, like, because in my opinion, like I'm just going to be like, okay, this person doesn't know the difference between like a pointer and a value, and like their main language is C++. So, like obviously it might be like a bad interview for you, you might be nervous, whatever, but I can only assume what I see, like I don't know your like background and whatever. Um,
Right.
so so definitely make sure you like brush up there. It's a harder language. I think, it's more impressive if you can do it well, but at the same time, if you get stuck on simple stuff, then you just like auto fail.
Yeah, I thought like, I definitely do know like, oh, they're connected by pointers, but I thought like, I was thinking like, oh, maybe that's like implemented in the linked list class. Like, oh, I'll handle like the pointer logic there. But yeah, I just like overlooked that.
Yeah, exactly. So if there's multiple ways to do something, at least know one of them very well, right? So if you can make it from scratch, or if you can use the standard linked list, like I have no problem if you use something from the standard library, because it's like it shows that things that are in there. It shows that you know how to use them. But if you pick it and don't know how to use it, then that's really bad. Or
Yeah.
obviously that's why I asked, because I wasn't familiar with it. I was like, how much does this stuff does it do for you? Because if it made a hash map sorted linked list class like everything, then I'd be like, okay, you can't use that, like so.
Yeah.
So yeah. I mean, honestly, I would recommend learning both, because then you can ask, and then if I say no, you should be able to do the from scratch. So I would recommend learning both. And like here, it isn't so much like linked lists. It's more just like how do pointers work? How do I like make a constructor? All that kind of stuff. And then obviously, how do I make like clean code? Because like here, uh, like after a while, it was like, can I just get something working? Because you were stuck for a while. So ideally, you want to be like, okay, how can I do it? And then how can I do it in a way that's like, I only expose the things that I need to expose and things like that. So that would be like the extra mile type of thing where it's like you make some helper class and you make sure you only expose the things that like you need to, and you don't expose internals and things like that. I think that would be like a very good signal from an intern, maybe like above and beyond, because like you probably don't have that experience. But like if I make something that something uses, I don't want to expose the business logic. I just want to expose the things that like it actually needs. Does
Yeah.
that make sense?
Yeah. Yeah.
Okay. So yeah, I think if you just like work on, I think you said you did around like 130 or something of the LeetCode 150. From my
Yeah.
experience, almost everyone that's done around this failed. So I think it just comes down to like more reps. Um, so usually I see people from like anywhere from 250 to 800 problems do well. Obviously, it depends on you and how well you study and like how fast you pick things up. But I think it's for you, it's more of a just do enough reps, and then yeah, make sure you don't pattern match. Make sure you understand the language well, um, and then make sure you can like problem solve and like have simple solutions. You kind of understood it too, like as you were doing. You're like, I'm writing this. I know it's bad, but I can't think of anything better. So, which does happen, but usually when that happens, that means you're kind of on the wrong track. Like if you're doing a solution and you're like, okay, I have to handle like these 10 random edge cases, you're probably just on the wrong track. I think that's a good sign of that. And I think you recognize it in the first problem, like as you were writing it, like, man, like I'm writing this, this is not good. Like there's got to be something better. Like so you have like the intuition that there is something better. So that's good, I think. So does that make sense? Like what you need to work on?
Yeah. Yeah. For sure.
Okay, cool. And then yeah, feel free to schedule another one once you like study up a little bit more and get a little bit better. And yeah.
Okay. Yeah. Cool. Thank you.
Okay, yeah. See ya.
See you.